Hi there, it's Mrs. Tollison with your Matter and its Interactions review video. This covers the introduction to matter, density, energy and chemical reactions, and mixtures. As always, it might be a good idea to have either your notebook or a piece of paper nearby so you can write down any questions you have so that you can bring them in and ask me. Here we go. Please feel free to pause, go back, review. You can kind of zip through to different sections that you feel like you need more help with. So as an introduction, we talked about what matter is and what it's made up of, and all of these topics will be talked about in more detail on the following slides. But in general, everything, whether it is living or not, is made up of matter. Earlier in the year when we talked about cells, we said cells are the smallest things that make up living things, but all cells are made up of matter, okay? All matter is made up of atoms, okay? And an element is the simplest, most basic form or type of matter, and it's made up of only one type of atom. And each element has its own unique properties. So anything that's on the periodic table of the elements is an element, okay? So an atom contains protons, electrons, and sometimes neutrons, most of the time neutrons, and you'll learn more about that in later grades. There are 4 states of matter, but only 3 are normally found on Earth: solid, liquid, and gas. And those are the ones we talk about mostly. And so energy, usually in the form of heat, needs to be added to a substance or taken away from a substance to move matter from one state to another. For example, you need to heat up an ice cube. Have to add heat to an ice cube to get it to go from ice to liquid water. You need to take away heat from water to turn it back into ice. And matter has certain properties, which are kind of characteristics that describe that type of matter, and that helps us to classify or group similar types of matter together, and it helps us understand how they'll react when they're combined with other types of matter. Okay, so everything's made up of matter, but the reason that it doesn't all look the same is because the building blocks, what make up that matter, are not the same. So matter, like we said in class, is anything that has mass and takes up space. So it's made of some amount of stuff, and kind of the amount of that stuff and how much space that stuff takes up is what makes something matter. So even if something is one single atom and it only has a very small mass and takes up a very tiny space, it's still matter. So some examples of matter are air, water, dirt, sugar, salt, oxygen, gold, milk, and I could go on and on. So mass, so when we talk about matter, we measure it in different ways. One of the ways that we measure matter is by measuring its mass. And the mass is just the amount of matter in an object. It can be measured on a triple beam balance or a digital scale. We did both in class. And that tells us how much stuff, for lack of a better word, is in the object. And the unit of measurement for mass is grams. And the amount of mass won't change if you go from place to place, because that's not affected by gravity like weight is. So again, the mass of an object is the mass, no matter where it is. Volume tells you how much space that object is taking up. And for an object with a regular shape, like a block, or something where you can measure the sides, you can just measure the sides, length, width, and height, and measure and multiply them all together to find the volume. For liquids, you measure the volume using a graduated cylinder. A graduated cylinder is the most accurate way for us to measure liquids. And the unit of measurement for solids is centimeters cubed, because if you have an object and you're multiplying like 2 centimeters times 3 centimeters times 2 centimeters, then it's, what did I say, 2 times 3 is 6, times 2 is 12. That's 12. You multiply the numbers together, and then centimeters times centimeters times centimeters is centimeters cubed. For liquids, the unit of measurement that we usually use is milliliters, because we're using smaller volumes. So matter can be classified as either a pure substance or a mixture. When we're talking about pure substances, we've already mentioned that we can talk about elements. So elements are anything found on the periodic table. They're only made up of one type of atom. So pure oxygen only has oxygen atoms, pure gold only has gold atoms, pure hydrogen only has hydrogen atoms. Compounds are made of 2 or more elements that are chemically combined. And if you look at this picture, it shows kind of 2 different colored parts like black and red. So that indicates that it's two different elements. This would be CO2, carbon dioxide, that has carbon and oxygen. Water is another compound that we talk about a lot, hydrogen and oxygen. Mixtures, which we'll talk a little bit more about later in this presentation. You can have two types of mixtures as well, but a mixture is just made of two or more substances that are chemically combined, that are mixed together, but they're not chemically combined, okay? So they can be separated physically. So if you look at this picture, a homogeneous mixture is a solution, which we'll talk more about later. It just means the particles are evenly distributed, so you can't tell the difference between one part of the mixture and the other part. Heterogeneous mixture, you can see the different parts. You don't need to know the terms homogeneous and heterogeneous. You'll learn those more in later years of science education. So like we said, all matter is made up of elements, and an element is just a substance that can't be broken down into a simpler substance. Okay, that's it. You can't break the hydrogen down into a smaller substance. And one element can't be changed into another one. Each element has unique properties or characteristics that can include but are not limited to how it looks, what's its shape, color, texture, size, how hard it is, how well it conducts electricity or heat, how it reacts with other elements, what the state of the matter is, if it's solid, liquid, or gas, is it magnetic, can it be stretched out into thin wires. There are many different properties, and density, actually, which we'll talk about a little more later, is another property. Atoms make up elements. Atoms are the smallest part of an element that has all the properties of that element. So, for example, like one individual atom of gold would have all the same properties and characteristics as a bar of gold, okay? Because those properties are specific to gold. We talked briefly about kind of how the particles that make up an atom are arranged a little bit, just to have like kind of an understanding of what an atom is. In the center of the atom is a nucleus, and that's where you find protons and neutrons. And we're not going to get into too much detail about that, but just an understanding that kind of how an atom is made up. And then electrons are the particles that kind of orbit around the nucleus, and they have a negative charge. And you'll learn more later that the number of protons, the number of positively charged particles that are in a nucleus, determines what element that atom is. So when we look at the periodic table, each different kind of element has a different number of protons in the nucleus of its atoms. So again, when we're measuring matter, if we want to measure the mass, we can use a triple beam balance. We practice with those a little bit. You can also use a digital scale to measure the mass. Okay, many of you probably have little digital scales at home for measuring food, and you can choose on those. Usually you can choose between grams and ounces, but we measure in grams in science. So when you, like the other day when we used the triple beam balance, once you've moved these riders or these sliding parts over, and this is lined up with 0, you just add up the amounts of the sliders or riders, and that's your mass. Kind of similar to we talked about if your doctor has one of those kind of old-fashioned scales that you step on, and they have to slide the parts over. So if you had an object on the scale and you had lined it up like this, the mass of the object, you would add the hundreds, the tens, and the ones. So this would be 542.4 grams. Okay. Again, in most modern science laboratories, you're not going to use a triple beam balance. You're going to use a digital scale. If you want to give it a try, we didn't do this a lot, but there could be a bonus question on the test about this. If you want to pause the video to see if you could figure out the mass shown on each of these examples and then check your answers on the next slide, that would be a good idea. So for this first one, it would be 200 plus 90, and over here this little pointer is just at 0.2, so it would be 290.2 grams. This one, it's at 530. And then this is 6.8, so if you add all those together, it would be 536.8. And this one, we've got 100, we've got no tens, so it's 100. And then down here, this is 5.6, so 100 plus 5.6 will be 105.6 grams. Another way that we measure matter besides mass is volume. And the reason we measure these two is because they can help us figure out the density of a substance, which is a property of matter. So the reason we focus on these two measurements is because they're important in kind of understanding matter and the property of density. So for volume, we're talking about the amount of space that an object takes up. Does it take up a little amount of space? Does it take up a big amount of space? The metric unit for volume is liters. A lot of times we've talked about in class milliliters. So 1,000 milliliters makes up 1 liter. And 1 milliliter is equal to 1 centimeter cubed. So those are equivalent measurements. It's just one of these is used for liquids, milliliters is used for liquids, and centimeters cubed is used for solids. So they both take up the same amount of space. It's just one unit of measurement is for the liquid state of matter, and one is for the solid state of matter. So how you figure out the volume of something depends upon, number one, if it's a liquid or a solid, and number two, if the object is a solid, does it have a regular shape where you can measure it with a ruler, length, width, and height, or is it kind of an irregular or odd shape, like I think I showed you a marble or a small rock in class? If it's a weird shape that you can't measure with a ruler, then that changes the way you figure out the volume. So if you're measuring a liquid, again, we use a graduated cylinder, and we practiced this a little bit in class. And when you're reading in a graduated cylinder, you want to make sure your eye level is here at this meniscus, this little curved area, and you want to read the level of the liquid down here, not up here at the kind of where the edge is, kind of where it's touching the edge of the graduated cylinder. You always want to make sure you pay attention to these what are called graduation marks, which is why it's called a graduated cylinder, which each of these graduation marks will help you figure out what the volume is. And for this example, we know that each of these marks is equal to 1 milliliter, because this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if we were reading this at the meniscus, this would be 14 milliliters. You don't read it here at the top where it says 15, or where it would be 15. Again, if you have an object with a shape that you can measure the sides, you would just carefully measure the sides, multiply length times width times height, and get your answer. So for this example, it would be 10 times 8 times 9. 10 times 8 is 80. 80 times 9 is 720. And again, the reason we have centimeters cubed here is because when you multiply centimeters times centimeters times centimeters again, you get centimeters cubed. Just like you multiply the numbers together, you have to multiply the units of measurement as well. So if you're measuring the volume of an oddly shaped object, in this case it looks like a small rock, we use what's called the displacement or water displacement method. The word displacement literally means to push something out of the way. When you put something in water, it pushes the water out of the way. It makes the water rise up inside the graduated cylinder, and the amount that water rises up is equal to the volume of the object. So we can know that however much the water level went up is equal to the equal to the volume of what we put into the water. And that's Archimedes' principle. He's the one that discovered that. So if we look here, the way we figured that out is we have to take two volumes. We have our we have this amount of water with the object in it. That's our final volume, which here is 260, because each of these lines is 20 milliliters. Then we have our starting volume of water, which is the amount of water without the object in it, and that's 200 milliliters. So then we take the difference, 260 minus 200, that gives us 60 milliliters. And then technically, you should, since the object is a solid, we should report that the volume of this object is 60 centimeters cubed, because centimeters cubed is the proper unit of measurement for a solid. Another example, like if you have this little plastic toy dinosaur, the volume of the solid is equal to the volume of the water plus the solid, which is over here, which is 5.6 milliliters, minus the volume of the water by itself, which is 4.8. So 5.6 minus 4.8 is 0.8 milliliters, or since it's a solid, we would report it as 0.8 centimeters cubed. So a question for you, which do you think would have a greater volume and mass, and why? Think about that for a second. Would it be 1 kilogram of feathers or 1 kilogram rock? Hopefully you got that both of them would have the same amount of mass. A kilogram is a kilogram. It's a measure of how much stuff there is, how much matter there is. So for both feathers and a rock, it would be the same amount of mass. What would be different is that the kilogram of feathers would take up a much larger volume, a lot more space, because it's so light and fluffy. It has a much lower density than the rocks, so in order to have the same mass, you would have to have a lot more volume of that material. So that takes us into density. Density is just defined as the mass per unit volume. Okay, it tells you kind of how tightly packed the molecules are in an object. Density is the amount of matter within a certain volume. So we have these two, you can kind of see the outline of these two boxes here. Okay, and this one on the left, this is more dense, that you can hardly see any space in between the particles. So there's more stuff, there's more mass, there's more particles in this one than there is over here on the right. Same size box, a lot more empty space, so it's less dense. Some kind of proof that you can see every day that water and ice, even though they're both made of the same type of particles, have different densities, is because ice floats when you put it in water. Okay? It floats in the water because it is less dense than water. If something is more dense than the liquid that you put it in, it will sink to the bottom. If it is less dense, then it will float on top. And if it's the same density, it will kind of hover in the middle. So this is true for liquids and solids. Okay? You can make something like a density column like that's shown here. Okay? Density determines whether something sinks or floats. We've got a bunch of different liquids here labeled on the left, and we've got numerous solid items labeled here on the right. Just because something is a solid does not mean it will automatically sink to the bottom in a liquid. When you make a density column, the objects create layers with the most dense or densest substances at the bottom and the least dense substances at the top. So you just look at the density numbers and you can put them in order. The smallest density number will be at the top, the biggest density number will be at the bottom. Like I said, all solids won't automatically sink to the bottom. It depends on their density. So in the column above, you can tell which items and materials are more dense or less dense than other items based on where they are in the column. Okay, the bolt down here is the most dense because it's at the bottom. Honey is the most dense liquid. Okay, the least dense liquid would be lamp oil, and the least dense solid would be the ping pong ball, and then everything else is in between. Okay, so to find the density of an object, you have to take those two measurements we've been talking about, mass and volume. So you find the mass of the object, either by using a triple beam balance or a digital scale. Then you find the volume. You can measure length, width, height. You can use the graduated cylinder, however you have to find it. And then the formula for density is mass divided by volume. So density equals mass over volume, or you can just use the letters. D equals M over V. That means division. Or D equals M divided by V. All of those are equivalent ways of saying the same thing. So the unit of measurement for density will be grams over centimeters cubed for a solid, or grams over milliliters, or grams per milliliter for liquids. And the reason for that is because the unit for density is a combination. It's telling you how much mass per unit volume. The unit for mass is grams. The unit for volume is either milliliters or centimeters cubed. So when we divide, you don't just divide the number, you divide the units. So grams per centimeter cubed, grams per milliliter. Similarly, I think I mentioned in all the classes, if you say mph, if you're traveling 60 mph, that's miles per hour. It would be miles over hours. It's the same kind of thing. So again, just if you want to practice, you have to have the mass of the object, the volume of the object, and then divide. Mass divided by volume. Okay? If the mass of an object is 35 grams and it takes up 7 centimeters cubed of space, calculate the density. So why don't you try taking a minute to set up the problem and figure out the answer. Write down the formula. It's always important to write down the formula. That way you're less likely to kind of put the wrong thing in the wrong place. And in this slide that I showed before, I forgot to point it out, somebody came up with this cute idea. If you kind of think of D equals a heart, okay, this kind of top part of the heart looks like an M, and the bottom part of the heart kind of looks like a V. So that way you remember which one goes on top and which one goes on bottom. So if you want to pause for a second before you try this problem, and on the next slide I'll show you how to do it. So again, in the problem you're given the mass, 35 grams. You know that's the mass because it says grams right next to the number. You know the volume is 7 centimeters cubed because centimeters cubed we know is a unit of measurement for volume. Okay, your density problem, D equals M over V. D equals 35 grams divided by 7 centimeters cubed. So you divide 35 by 7, that gives you 5. Grams divided by centimeters cubed gives you grams per centimeter cubed. Okay, so density is a physical property of a substance and doesn't change if the amount of the substance changes. You can have a large amount of the substance and you can break off a little piece of that substance, whatever it is, the densities will still be the same. For example, if we were going to measure water, if we took the mass of 50 milliliters of water, it should be right around 50 grams. 50 grams divided by 50 milliliters, 1 gram per milliliter. Okay? If you had 100 milliliters of water, it would be 100 grams. You divide that, 1 gram per milliliter. So density is the same in both cases, even though the masses and the volumes were different. So if the mass of an object changes, as long as it's the same substance, the density will stay the same. It does not matter if you have a little piece or a big piece. So finding the density of an unknown substance can help you determine what that substance is by comparing it to tables of known values. So it's a helpful piece of information to have. Finding the density of an unknown substance can tell you if that substance will sink or float in water. Density of water, pure water, is always going to be 1 gram per milliliter. So if the density of a substance is more than 1 gram per milliliter, the substance is going to sink if you put it in water. If the density of the unknown substance is less than 1 gram per milliliter, the substance will float on top of the water. Okay, or float in the water. It won't be directly on top of the water. It depends on the density. Part of it might be under the water and part above the water. So knowing the density of a variety of substances allows you to figure out how they would form layers if placed in a graduated cylinder to make a density column, like I showed on a previous slide with all those different liquids and solids. The next thing we talked about in our matter unit was chemical reactions and how there's energy associated with that. Chemical reactions occur when there are 2 or more substances combined to form a new substance or new substances. Okay? Compounds are formed when 2 or more atoms of different elements are joined together during a chemical reaction. Like if in a chemical reaction between water and oxygen, they combine to form H2O or water. There are several different pieces of evidence we can look at to tell us if a chemical reaction has taken place. If you see gas is forming, usually you just see bubbles, okay, and that tells you that a gas is being produced. An unexpected color change, the key is that it's unexpected, okay? The other day in class, we combined, yellow water that I'd colored with food coloring with blue water that I'd colored with food coloring, and it turned green. That's expected, okay? That's not unexpected. If you combine like a white solid with a pink liquid and get something yellow, that's unexpected. That's evidence of a chemical reaction. If there's a change in temperature, whether the substance gets hotter or colder when the reaction is taking place or when you combine things, and if a precipitate or a solid is formed. I showed you that example of combining copper sulfate and ammonia, and kind of a powdery blue substance formed when I combine those 2 liquids. The compounds, whatever you make in a chemical reaction, is going to have different properties from the original elements that make them up. Okay, I think I mentioned in all the classes sodium chloride, which is salt that a lot of us use on a daily basis. Pure sodium is a metal that reacts explosively when it's put in water. Pure chlorine gas is toxic, it will kill you. But when they are combined in a chemical reaction, they make sodium chloride, which has very different properties. It's a solid, a white solid that you can sprinkle on your food. So some examples here of chemical reactions: a change in color. Bleaching your hair changes its color. That's a chemical reaction. Change in temperature. When you burn wood, it produces heat. That's because the wood there's a chemical reaction happening that's breaking down the wood. Production of a gas, like if you put an antacid tablet in water, it produces bubbles. That's a chemical reaction. You can produce a solid. If you add acid to milk, it produces a solid, which is cottage cheese. So when we talk about chemical reactions, there's like two sides of the story. Kind of in math, you put an equal sign here a lot of times for equations. In science, there's an arrow. You start off over here on the left with your reactions. It's what you start off with, what your ingredients are, what you're mixing together. And then this arrow indicates that there's a chemical reaction, there's some kind of process or process occurring, and what you end up with over here on the right is your products. Okay, this is what you end up with, what produced your ending material. So what is made in the chemical reaction. Reactants are always on the left, products always on the right. So the two kinds of reactions we talked about are endothermic reactions. These ones need to absorb or take in heat in order for the reaction to take place or while the reaction is taking place. The prefix endo means inside, so the heat goes in or is pulled in. The products, what you end up with, are often colder than the reactants. For example, the cold pack in class that we did, or when in the lab when we mixed lemon juice with baking soda, we measured the temperature and it got colder. Another example of endothermic reactions are ones that require heat in order for them to take place. For example, if you want to bake a cake, if you mix the batter together, it's not going to become a cake unless you add heat. Okay? If you want to cook an egg, it needs to absorb heat. It needs to take in heat in order to cook that egg. Exothermic reactions give off heat as the reaction takes place. The prefix exo means outside. Heat comes out. Heat is exiting. Or if you think of the word explosion, that's a big exothermic reaction. So heat is kind of exploding out. The products, what you end up with, are hotter than the reactants. Some reactions give off a little heat, like in our lab activity, the beef liver and hydrogen peroxide give off a little bit of heat. Some reactions give off a lot of heat. Dynamite exploding, that's a reaction that produces a lot of heat. So kind of what does it look like? We used our thermometers in our lab to determine if reactions we were observing were endothermic or exothermic. So if what you're making ends up being hotter than the surroundings, that's exothermic. If it's cooler, it's endothermic. So when we were using our thermometers, if we noticed that the temperature was going down, that means it's an endothermic reaction. If the temperature was going up, exothermic. And you have this in your notebook. Another way of kind of displaying it. Again, energy is absorbed or taken in. So over the course of time, this is temperature and time. So you start off with a temperature up here and temperature goes down. That means it's endothermic. Or your reactants have a higher temperature than your products. Your products are colder than your reactants. Temperature goes down, endothermic. Exothermic, starting temperature, and then as the reaction progresses, temperature goes up. Okay, energy is released or given off. Your reactants are cooler than your products. So mixtures occur when two or more substances are mixed together, but they're not chemically combined. Because they aren't chemically combined, mixtures can be separated physically by using what you know about their physical properties. So some mixtures are going to be easier to separate than others. Okay? Sometimes you can see the different parts of a mixture, but sometimes you can't. Solutions are a special type of mixture where the parts are so evenly spread out that you can't see the different parts. Okay, and we did this hook in class. You should have this page in your notebook where I combined yellow water and blue water to make green water. Okay? It's a mixture. The yellow and the blue water are still there. It's just they're so evenly distributed, the solution appears green. So this is a solution. We cannot see the different yellow and blue particles that are making up the solution. I also showed you a mixture that would represent this heterogeneous mixture over here. You can see the different parts. It was a bag with different colored beads in it. So this, the different parts are visible. It would be much easier to separate a mixture like that. Okay. So we did, a little activity in class which talked about separating mixtures based on their properties. So if you know about the properties of a substance or a mixture, it will help you figure out what tools that you would need to use, or what processes you would need to use to separate it. So if you have two substances mixed together and one of them is magnetic, okay, like iron filings, which are teeny tiny pieces of iron, you can just simply use a magnet. The magnet will pick up all of these little pieces of iron filings, and you'll be left with just sulfur behind. If you have a solid mixture that's made up of particles of different sizes, you can use a sifter or a strainer. Here it says sand and gravel here, to separate the smaller parts from the larger parts. The smaller part will go through, the bigger part will be left behind in the strainer. You can separate a solid from a liquid using a filter. Okay, you can use a funnel with a filter paper in it, like a coffee filter. You pour the muddy water through, you end up with clean water in your beaker or flask where you're collecting it, and the particles are trapped on the filter paper. Sometimes you need to do multiple steps, like down here, if you've got a combination of sand and salt and water, okay, you can mix the sand and salt combination with water, okay, and then you pour that mixture through a filter, or well, this says through a strainer, you can filter it as well, but through a strainer. You keep the sand in the strainer, you've got salt water down below, so now you've separated out one thing, you've separated the sand, but the salt and the water are still mixed together. Then you can come over here and you can boil off the water, or you can let it evaporate in the air, that would take longer, but you can boil off the water and you're left with just salt. Okay? If you had a mixture of iron filings, which are little iron pieces, rice, sugar, and sand, you could use the steps below to separate the four solids in the mixture. The last thing you want to do is the water, because that's going to make everything kind of clump together. First, you would use a magnet to separate out the iron. Okay, so now what you're left behind with is rice, sugar, and sand. Okay, rice is bigger than sand and sugar, so you can use a strainer to separate out the rice. So now you've got a mixture of sand and sugar. Okay, you put the sand and sugar mixture in water. That allows you to separate the sugar from the sand. Pour the mixture through a filter inside a funnel. Now you've got the sand in the funnel, and you've got the sugar water collected below. Then you would have to evaporate the water using a hot plate to separate out the sugar. Okay, that is it for this review video. Please feel free to ask me any questions in class, and have a good luck on the test.